one triple integral, and I want you to do it in this way, 2 plus 1. It's obvious, right? That's what exactly what you're doing. And in 2, you need to be polar. That's what I'm going to. Well, the typical case to be polar, you have to be in a good shape. Say, paraboloid. That's a typical case. So let me give you an example of how you're going to do it. Pretty much you're going to repeat the triple integral over E. Instead of just looking for volume, I will give some function friendly in terms of triple to be that say x squared y plus y cubed. Yeah, something like this. That would do pretty much what you can ask for in triple integral. What is the E? E will be given a picture. So the paraboloid always look like this. And then you truncate this by a certain level z. Let's say z equals 17. All right? That's it. So at the level 17, you have paraboloid above that. So whatever E is here. So you needed to do two things. Because this is not a double integral, it's triple integral, and you need to identify the domain over which you're in the form of type 1. So what is E? E has to be type 1, which means z greater than x squared plus y squared, less than 17 all the time. No beyond 17, always above the paraboloid. However, how much is z x y to go, you have to determine in this case, not given. To determine this edge, you just let z be 17 here. So this is a circle under beneath the surface that you define two pieces, right? So this is D, 17. So that's the preparation part. But if you really want to get through, you don't want to jump into something that eventually be wrong. So this is a key step actually. So the radius is square root of 7. So let me show you how to compute this. So triple integral by virtual, if you're in the type 1, like this situation, it's 2 plus 1. So leave d like this, but z goes from x squared plus y squared to 17. Of x squared y plus y cubed and dz. You integrate z first, you follow by a double integral, which is dA. That's how we do a triple integral. Now you see the reason why I'm not giving anything to z variable, because I want to simplify the situation. So you integrate in just one in terms of z. So whatever the answer is, 17 minus x squared minus y squared times x squared y plus y cubed dA. So you almost get halfway done because of the setup. You reduce the triple integral into a double integral.
Why is it multiplied by x squared y plus y cubed?
Because you're integrating one. This is constant.
Yeah.
One integrated is z. Z taking difference between these two. That's that. Okay? Obviously, this is a polar situation because of the circle.
Is that 17 minus x squared minus y squared there?
Yes.
All right, good.
17 minus x squared minus y squared. No, it looks very ugly. Beware, is the square root of 17 you go through because the radius, not 17. So this is where make sure you know that's the y. And then everything else substituted by r squared. Most of them is r squared. And this x, y is a common factor, giving another r squared. Y is r sine of theta. Okay, so I should have written here. It's y, x squared plus y squared. This is r squared. By the way, this is not a 17. The 17 only true on the boundary. Inside of the disk, it's not 17. It's the radius, which is r squared. Right? So make sure do not substitute 17. And that's this. And you still have r. Yeah, it looks a very complicated integral, but actually very trivial one because of the separation of the variables. So the integral being separated between theta and the r. And the r part is just a couple of algebra you have to deal with. R squared 1, 2. Onto the 4th. Right? This integral, for some odd reason, is 0. So you don't even have to integrate this. All right? But if we do have to integrate this, by the way, this is also simple. It's just r to the 4 minus r to the 6. You integrate in this, which is 17 over 5, r to the 5 times 7, r to the 7, and so on and so forth. Yes.
Back where your left hand is, I know all the algebra. How you got the roll of 17 minus x squared minus y squared. Look to your left, down, right
This?
there. Yeah,
This?
up. I didn't follow that
Yeah,
step.
this,
Yeah.
how do I get this?
How do you go from above to right there?
From here?
Yes.
Okay. I thought you asked that. No, no.
I did, but I
If
didn't.
this is a constant, you're integrating 1.
Yes.
So the integral is giving you z evaluated from x squared plus y squared 17. Instead of a constant in front of it. This is a multiple to z.
Yeah.
So, well, I know I kept this outside all the way. Instead of with it, each time you take a difference, which is the same when you take a common factor. So I'm basically doing z in difference of these two, and then I have that. Or you could take this along with 17 this, minus this, times this, but the algebra is the same.
But why are they being multiplied right there?
This was multiplied?
Why are you multiplying those two things together instead of?
Well, this is a scalar multiplication of z.
Yeah, I got that.
When you go through the integral, you get constant at the front.
Yeah, but you have 17
Minus.
x squared minus y squared. You multiply it out.
All right. Let me figure out what you're thinking. That's what you're doing. Right? Well, depending on how you're going to integrate this. Preferred way would be this.
Yep.
This is your constant. So you take out of the integral. You integrate 1, which is z. So z has the ends of that divided from. So what do you mean by this? It's the difference of z. So you automatically get it. This is 17. You automatically get a product.
Thank you. I'm sorry, I just wasn't seeing that.
I thought you were supposed to do some experiment. Being a physics teacher. Next question.